Okay, so hydrogen fuel cells are a special type of galvanic cell to generate electricity where we're continuously feeding in the fuels. So we're feeding in some hydrogen gas and some oxygen gas. Now, I've already put these in the correct positions, but the way to remember it is if you look at on our electrode potential table, hydrogen only exists on the right, so it's always oxidized. Remember, anything on the right is oxidized. Oxygen, you can see, only exists on the left, so it's always going to be reduced. So that may help you actually remember that reduction, remember, always occurs at the cathode and the oxidation always occurs at the anode. So this is why it says the way round. So what we're having is we feed in oxygen and it can escape for any extra, feed in hydrogen and any extra can escape, and we can feed in oxygen and any extra can escape out this way. We also need some way of actually draining out waste water that's actually going to be generated as part of this. So in the middle we can have an electrolyte. Now that electrolyte can either be acidic with hydrogen ions present, or it can be basic or alkaline with OH minus. So we need to know how do we write the reactions in terms of that. So we need to do both acidic and alkaline conditions. So if it's acidic, what we have in the middle is an acid. We'll also have the other part of the acid, but we're going to focus on the hydrogen. So anytime it's acidic, we're going to look at where we have H+. So we're going to look at our standard electrode potential tables for H+. So remember that at the anode, the hydrogen is being oxidized and we want the hydrogen with a H+. So we're going to look for the H+ with the hydrogen, and that's a hydrogen with a H+. So we're going to have an oxidation of hydrogen to form my two hydrogen ions plus my two electrons. And those two electrons can then go across and be used by my oxygen to be reduced. So my oxygen, in this case, I'm looking for the oxygen with the H+. So I'm looking for oxygen with a H+. This is an OH minus, we don't want this one. We want oxygen with the H+. So we're going to use those hydrogen ions. So we're now providing an extra 2 hydrogen ions going in, and they migrate across to be used at the cathode. So my hydrogen plus my 4 hydrogen ions to make, let's do this correctly. I need because this is reduction, I need my 4 electrons as well, and then that makes water from that. So at the moment I have an imbalance of electrons. I have 4 and 2, which means I need to multiply everything up here by another 2. And my total reaction is my 2 hydrogens plus my oxygen gas. And then my hydrogens also balance out. So I've got 4 up here and 4 as products and 4 as reactants. So they will not appear in the net equation. And then I have a product of 2 water, which is my waste that comes out here. So I can actually see for every oxygen I need 2 hydrogens. So now if I've used 2 hydrogens, I've actually got another hydrogen molecule coming in. So I now have these 4 hydrogens here, which migrate across and are used up by the oxygen to make water. So I will not actually use up this. So this is because the hydrogen gas is actually creating enough of those hydrogen atoms to continue this process. So then I can have it in, so this is acidic conditions. The other conditions I can actually have is if we have basic conditions or alkaline conditions. So in this case, I have hydroxide ions. Now again, we always start with our oxidation because we need those electrons. So my hydrogen is coming in, and in this case, I need to find a hydrogen that also has an OH. So we're looking for the hydrogen on the oxidation side. So we have this one here. So in this case, we have our oxidation of the hydrogen. And in this case, we're also going to need 2 hydroxide ions, and then that will make my 2 waters and my 2 electrons. And I need to look for a oxygen that also has hydroxide ions in. So here I've got my oxygen and it also has hydroxide ions in. And I need to use some water. And so plus 4 electrons, sorry. Plus my 4 electrons to give me 4 OH. Now again, I've got my imbalance of my electrons, so I need to multiply everything by 2. So now I can cancel out my OHs because they appear on both, and I cancel out my electrons, and my net is still my 2H2 gas plus my oxygen gas. And in this case, I also need to look at my water. So I had 4 on the products and 2 on the reactants, so net I'll only have 2 water produced. So again, I have the same reaction, but it's been facilitated with the hydroxide in this case. So what's actually happening is that the hydroxide are migrating towards the hydrogen, and they then facilitate the formation of water plus those electrons. The water is then able to be also used with the electrons by the oxygen, but it will still produce some excess water in the final result, which is removed as waste. So my hydroxide ions, there's no net disruption because the oxygen produces some hydroxide ion. It doesn't use up all the water. So it only uses 2 of the water rather than 4, so those 2 extra waters are going down here from the hydrogen, and the 2 waters are being used by the oxygen and replenishing the OH, so we get some more OH coming in. But net equation-wise, still the same.